Okay, so I enabled the recording, and thanks Tomasz for finding time to chat with me today
No problem.
about the CI/CD daemon and Firecracker, the Amazon product they use on AWS Lambda and Fargate. That makes
Uh-huh.
it much easier and more efficient for them to run virtual machines, reduce the cost and time, and this could be something we could use to replace Docker machine executor we have right now or augment it somehow. So it's not clear yet, but uh, this is merely an idea, and the Firecracker has been mentioned by one of the CI verified CI team members. I think it was Marius Bobin who mentioned this project. I have not heard about it before. I had not heard about it before. And yeah, so I also wanted to talk about CI/CD daemon. What would you prefer to start with?
Uh, maybe let's start with the firecracker. It's probably smaller scope than the
Yeah,
CI/CD demo.
yeah, definitely. I will take my notebook as well. I will keep some notes here. So yeah, so the idea is that basically we are currently using Docker executor as, and we recently discussed the problem of Docker machine not being maintained anymore, and that it will reach the end of life probably in a couple of months from now. And that might be a good opportunity to think about what could we replace it with. And my idea is that we could create a service and an API client in GitLab Runner that would communicate with the service running somewhere in a bare metal machine or perhaps in the cloud. That would then make use of Firecracker to isolate builds. But I wonder if there is a way for us to actually calculate costs or somehow decide whether this is a viable solution or not, regardless of whether we need to replace Docker machine or not.
Well, let's start with that. We already started discussing in the runner team that we need to migrate off Docker machine. We started discussing this more than a year ago. So few months after Docker machine was mentioned to be not maintained anymore. And Firecracker, the way how it works, after I checked it recently, it could fit in one of the ideas that we had. Because somewhere at, I think, January, February last year, we've made an experiment. Three of us, Kamil, Steve, and me, we've chosen each of us chosen one of the ideas that we had how we could replace Docker machine, and we spent a week or two on trying to prepare a proof of concept, maybe even not implement it, but describe how it would work. And the idea that Kamil came with was that we should not handle autoscaling in Runner at all. Like Runner should not think about scaling the environment, because supporting autoscaling is hard. It's a complex task. And there are probably people, communities that do this better. We should try to use what exists already and just try to fit it to the runner to just ask for a place for the job execution for the environment, and then jump into this environment and do what the runners does best. And the idea that Kamil proposed was to use Kubernetes, but not with the Kubernetes executor that we have now, but Kubernetes running aside of the runner and being the engine for autoscaling. The Kubernetes would manage autoscaling nodes. For example, in GKE, you can define that the cluster should be autoscaled. So we now don't need to think about scaling the VMs. We only need to communicate with some existing Kubernetes and schedule a pod creation. But because why we don't use Kubernetes currently
Right
for
now,
shared
yeah,
runners, for
it,
example,
it
because
yeah,
of
it's
security
obvious.
problems.
Yeah,
Because of
and
security
Firecracker could
problems.
solve that. Yeah.
First is the need for the privileged mode because Docker in Docker approach is still too popular to drop it. Second, even if we would drop the Docker in Docker approach, it's still risky to execute two jobs from two random projects on the same VM. And with Kubernetes, we don't have full power on what VMs we will use. So what Kamil proposed was that we don't use the Kubernetes executor per se, but we use Kubernetes aside of the runner to create a pod in which we always start the same container to create a fully virtualized VM in probably nested virtualization in, let's say, GCP. And then what runner gets is access to this VM inside of the pod. This is, for example, how MacStadium handles the macOS cloud at this moment. They have their internal Kubernetes cluster that the user don't have access to at all because this is their internal implementation of the autoscaling. And they have their own API that communicates with this cluster, schedules the pod, which creates a VM inside and gives the user back SSH access to this VM. So we wanted to do the same, but we were stopped at the moment how to manage creation of this internal VM in a good way. And at this moment, we finished the discussion about the POC with, this is an interesting idea. We would like to experiment it further, but we didn't get back yet to this problem. And now the Firecracker that you proposed
Solves that problem.
just fits perfectly into this blank space.
Yeah, so it appears that the Firecracker has been also integrated with container library. And I wonder how easy it would actually be to configure a Kubernetes cluster using container backed by a Firecracker library. Perhaps it could be like a matter of, simple configuration, a couple of lines of configuration to use Firecracker micro VMs instead of containers. And this could be transparent to the Kubernetes itself, the runner, and it could be like interesting solution, but without giving it a try and building the cluster like that, like it might be difficult to answer this question.
But from what you say, it's like not implement a new type of executor, but use Kubernetes executor that we have already, but with the Firecracker being the
abstracted mechanism of creating virtual machines.
To create a secure, because Kubernetes executor works as the Docker executor. It executes the job inside of a container, the container that you can specify by yourself in the GitLab CI YAM file. Now, if we would like to use Firecracker as just a virtualization layer to separate,
we need to have a Docker engine inside.
We need to have Docker engine inside. We need to do more or less what Docker machine is doing. So
yeah, but Firecracker seems to be a virtualization technology built on top of KVM. And I'm pretty sure that we can configure it in a way that it takes an image of a virtual machine, and we can put everything we want there. We can put a Docker engine inside this virtual machine, this image of a virtual machine, and probably pretty much everything else we could dream of. And this could actually, become a full replacement.
This still makes it not suitable for the Kubernetes executor that we have now. Because with the Kubernetes executor, what the runner does, it creates the pod specification.
And it expects a container running inside.
And this is where we define the containers that the user defined. What we need to do is have another type of executor that will use Kubernetes, but to create Docker engine VMs in a way like Docker machine executor works, right?
So why can't we perhaps extend Kubernetes itself in a way that a pod becomes a Firecracker virtual machine?
The way how Kubernetes executor works is totally different. We don't work with Docker in Kubernetes executor. We don't work with Docker itself. We just work with the pods. We don't schedule. We schedule a pod configured from the user-defined images for the job and for the services. While here we would need to schedule a pod with our configuration for Firecracker that starts Docker engine inside and where we want to connect to this Docker engine. So this is more the way how Docker machine executor works right now. Where
okay. But
Docker
I feel
machine
like
is the abstracted mechanism that creates the Docker engine host and give us the credentials. And just let me finish one thought. One of our ideas to migrate off Docker machine is creating a concept of custom Docker provider. A few months ago, at the beginning of last year, we introduced a custom executor in GitLab Runner, which give you an abstracted interface, how you can hook into how the executor works. And at this moment, we don't accept any new executors implemented in Runner code base itself. If anyone wants to implement a new type of the executor, it must go through the custom executor interface. And the follow-up from this was to do the same with how Docker machine works right now. Because Docker machine executor is a wrapper around the Docker executor. Docker machine executor, what does, it's handling the auto-scaling and using Docker machine to spin up a VM, give us a credentials to a Docker engine, and then these credentials are passed to the internal Docker executor, which is the same Docker executor that you can use directly.
Yeah,
and
I think
we wanted to abstract the behavior of Docker machine to something named Docker executor provider or Docker provider or custom Docker provider, something like that. Mm-hmm. And then Docker machine would be one type of this provider, and we could implement a new one. And this is a place where we could experiment with Kubernetes with Firecracker, because Kubernetes, we would prepare a driver for such custom Docker provider, which would use Kubernetes cluster, configured to use Firecracker to create a VM with Docker engine inside. This would give us back the credentials to the Docker engine, and then we would inject this to the internally running Docker executor, which we already have and is working as we expect. Yeah. So we just extract this whole Kubernetes play with Firecracker outside of Runner itself, and outside of executing the job. It's to prepare the environment only.
Okay. One moment.
And to be honest, we have already a place where we could extend this to use it right like that.
Okay, so that's very interesting. It appears that this could be like multi-step process. One step is to replace Docker machine with something that makes use of a Firecracker and becomes a Docker provider executor. Then we could mix that with Kubernetes executor perhaps, or reuse some parts of code to extend this. Why not?
No, because
what I'm trying to achieve here is to have Docker machine plus autoscaling extracted from GitLab Runner.
Yes, and this is why we don't want to hook into Kubernetes executor, because this is a different concept of working. Kubernetes executor directly executes the job on Kubernetes cluster. And we don't want to do this here. We want to use Kubernetes externally to provide us a virtual machine with Docker engine.
Okay, so that's, I feel like that's
It's
an implementation detail, but I wonder if you perhaps know what's the difference between a firecracker and regular KVM virtual machine. Like, why is it actually lightweight?
uh, I I don't know these differences. I From what I read, I only see that there is already a proven configuration how you can start such VM from Kubernetes, and this is why this becomes usable, because the biggest problem with the Kubernetes approach proposed by Camille last year is that uh, configuring auto-scaled Kubernetes cluster in GKE is simple. It's just we already have some Terraform scripts in our infrastructure that create such clusters for, like now, the sidekick fleet for GitLab.com. So we already know how to do this. The problematic part is that we need to start a pods with a configuration that will start internal VM, and this needs to work with a nested virtualization because the GKE cluster itself works on the virtual machines. And this was something unknown for us. This was something that we would need to work out. And from what I read in the Firecracker documentation, this is the problem that they've solved. So they give you a working configuration, how to configure a pod specification, how to create a pod that will give you this virtual machine inside of Kubernetes.
So that's
So
what's extremely interesting for me is why Google has chosen to invest into gvisor instead of using Firecracker, because it
I
appears that
have no idea. Like
it appears that
Giv
yeah
yeah.
it appears that AWS uh, Lambda is running on top of Firecracker, and it's efficient, cheap, so it appears it works. But Google has decided to build Cloud Run, which is, you know, the Lambda on Google on top of gvisor, and I simply can't understand the reasons behind that. It appears that they still want to use containers but make them more secure, whereas Lambda decided to use virtual machines for better isolation.
Yeah, yeah. From what I remember, gvisor is just another run C implementation. So it's still a container. It's just more secure than containerd or plain Docker. But it's still container. It's still the shared kernel. It's still vulnerable
gvisor
for all of.
is a layer between a shared kernel and user space. It's additional
Yes.
layer that they
Okay.
put in between to abstract.
But this is not a virtualization.
No,
Yeah,
that's microkernel, let's say that. Well, yeah.
and this still means that with certain vulnerabilities you are able to
Break the
just
isolation.
escape to the host kernel.
Yeah.
With the full virtualization, this is way harder. It's like virtualization is now 20 years old. Containers in the current form, it's still probably a hype of last 5-6 years.
Okay.
Google was using it for more years, but it's still not as proven as the virtual machines.
So I have a
I have
question.
no idea why they chosen this. Probably because this is their tool, and why to use your concurrency tools.
So I wonder, because I think this is a very interesting initiative, and we should spend more time talking about that and eventually start working on that. But in my perspective, from my perspective and from my experience, in order to expedite work on things like that, it would be great to align that with some significant cost savings. And I think there is a huge room for saving a bunch of dollars here, because like we can get much more efficient with the mix of Kubernetes and Firecracker and auto-scaling in a different way than we are doing that right now. And I wonder, what approach can we take to make some predictions about whether we should actually save something or not, or perhaps this is going to cost us more. Like, it's very difficult to predict, because I know that we are trying to make efficient use of virtual machines, that we reuse them, that we do have only a bunch of idle machines and stuff like that. But yeah, how to get data on that and how to predict.
At this moment, I don't think this is as important because we have a bigger problem. Docker machine is unmaintained, and we need to find a way to exit from it. And this is already a big problem for the runner team that we are looking on. And the cost saving part will be just a very nice and very expected side effect, but the main thing that we need to do is just stop using Docker machine at all.
Yeah, but in order to stop using Docker machine, we can find different solutions than Firecracker. Firecracker might be interesting, but not necessarily the most simple solution for.
And the first thing that we need to do is to extract the custom Docker provider interface, like we did with the custom executor, because having this, we can then experiment with different ways of handling the scaling. We can use Kubernetes with Firecracker and don't think about autoscaling at all. Or we can try to use our new project named Autoscaler that we created for Windows shared runners, and again implement autoscaling by ourselves, just not use Docker machine in this place. So the first thing that we will need to do, no matter which direction we will choose, is to create this custom Docker provider interface, because this opens us a way to start supporting autoscaling for Docker executor in different ways. And this would also make the Windows Docker executor also applicable for autoscaling.
Okay, but it also seems like an implementation detail. I wonder, how can we get data to back up our assumptions about possible cost saving and the viability of Firecracker versus something different, like we could, rebuild Docker machine GitLab way and not worry about virtual machines created using Firecracker at all.
How we can get data? Like think about this in that way. At this moment, shared runners are using VM explicitly for one job, and only once. And these have two side effects.
Only once? I thought that we are reusing the VM to run a few jobs.
Only on the private runner managers and GitLab shared runners managers.
That's
for the shared runners managers, we are using the machine only once because of security aspects. It's using Docker directly on the VM, so there is always a risk that the user will escape from the Docker container and leave something on the host machine, which next will try to access.
Yeah, I know that's not secure.
Code from the.
So
this have two side effects. First, we waste time on creating and destroying the machine, which also is a time where the machine is counted as existing. So we are paying.
How many machines do we create and destroy each day?
Something about several thousands for shared runners only. We execute
several thousand, like it's 10,000, 20,000.
Let me take a look on the graphs. Let's select shared runners only and last 24 hours. And let me share the screen so you will know what I'm talking about.
Yeah, because I think based on some data we currently have, we can actually get a little more understanding.
Okay, so here you have a graph of
I see it.
number of jobs running only on our shared runners, so the ones that are using the VM only once.
Oh my God!
So
it feels like
at this moment, 16 UTC yesterday, we had 1.5
What's the rate
thousand.
of this graph? Is that per minute or per second?
This is the gauge. So this is at this moment, at the moment of scraping, we have 100. We have 1,500 jobs.
If this is a gauge,
This
okay.
means
So
that
what's the
each
scraping
value
interval? The scraping interval is 1 minute.
15 seconds, I think. So this
Okay.
this shows more or less real life values. I need to look on our metrics. I think we should have somewhere a counter that could give us a rate, how many machines we create.
Yeah, I think that we do need rate.
Let me check this because we had something like that. Autoscale machines and machines count here.
Right.
Created. And this is operations per second. So seven machines created per second here, more than 7 here.
So I think that the average here is something around between 4 and 5. Okay, so let's assume that it's 5 per second, 5 machines
times 86,000 seconds per day, and this will tell you how many VMs we use every day on Runners.
Can you open a calculator? This is going to be like insane amount.
Do you see it? No, you probably don't see it.
Because I have some assumptions. I have assumption that creating a virtual machine and tearing it down on average takes more time than running a job. That is.
This is very probable because do you see my calculator right now?
Yes. So
okay, so we have so many seconds in
oh my God,
a
day. I can't believe it.
And if we have let's take the average of created machines, removed, used. Okay, let's say that the 4.
Yeah, let's see.
So it's
oh my God.
350,000 of VMs created every day,
so
while the average job time.
Yeah, average job time. Okay, that's super interesting.
Average job time on the shared runners. Here you have average job time.
Let's see 50 percentile.
It's below 3 minutes.
Oh my God, 3 minutes. And it probably takes more than five minutes to create one and tear it down.
You have machines creation timing. So the 5th percentile is 30 seconds. So one third of the lifetime of the machine.
How long does it take to tear a virtual machine down?
I think we don't have a metric for this, but it's usually longer because we need to wait for the disk to be removed, and it takes a little time in GCP. And then we need to wait for the VM to be removed. And I think we are counted for the VM until it's physically removed from GCP.
So it appears, let's assume that it's 60 seconds to tear it down. So it appears that 50% of the billing per job is basically tearing down and creating machines. So
probably
like very hypothetical assumption is that we could save 50% of cost. Like that's very hypothetical. Let's say 40.
Yeah, I think we could look on this in that form. And there is a second problem. Docker machine executor for now allows you to execute only one job on the VM at once.
Yeah, I know. And with Firecracker, we could like do 5, 10 in parallel.
Yeah, so we could create a big VM,
bigger machine,
like not even not bigger machine, even using the N1 standard 2 that we have now for the GitLab Shared Runners Manager. When we run GitLab project tests, it mostly would use the whole machine because we have a lot of things happening there.
Yeah, but we have a lot of tests.
Yeah, but for a simple jobs that users are doing, like echo hello world, we could fit tens, hundreds of such jobs on one VM. We can do this with Docker machine, but
that's exciting.
with Kubernetes and Firecracker, we have the isolation provided by the virtual machine internal one, but Kubernetes can see that this pod is in fact using 5% of the CPU, so I can still schedule another pod on the node.
Okay, Thomas. So it appears
this
like
plus auto scaling of the GKE cluster makes the auto scaling form totally different than what we have now.
Okay, Thomas. So is that a valid assumption that based on the data that we saw today, we can expect, of course, this is only an assumption that we need to confirm, but we can expect around 50% of cost reduction?
I think yes. I think we should look on this like that. We already talked with Kamil in the past multiple times that if we could even only how it's named in Docker machine, reprovision the VM, not remove it totally, but reprovision it. So
like
it's
clean it up.
Yeah, it's flushed with the clean base image, but we don't waste time on removing and creating again. We already talked in the past that this would be a big improvement, but not every cloud provider that Docker machine supports the reprovision. So we couldn't implement this into the executor. So even with this, we should have already a big cost saving, and then being able to execute multiple jobs on a node, which Kubernetes does by default, it's the next level of cost savings.
Efficiency.
And it's really hard to say how
predict.
much because we
My
can't
gut
predict
feeling
what
is,
the users are doing.
My gut feeling is that with Firecracker and with running jobs on Kubernetes, instead of managing autoscaling the dump in GitLab Runner, the cost saving might be higher than 50%. That's my gut feeling. And I might be wrong, of course, we need to make experiments. Anyway, let me summarize that a little bit for people that might watch this video. It appears that currently we are running around 345,000 jobs in each 24 hours. It's 345,000 virtual machines because we create one machine per job. It appears that the 50th percentile of jobs we run on Shared Runner takes less than 3 minutes. And our estimations are saying that creating a virtual machine and tearing it down might take more than a minute, probably 1 minute, 30 seconds. It appears that 50% of time is wasted on creating a machine and removing it. And we are being billed by that time. By using Firecracker and Kubernetes, we can reduce the time we spend on creating virtual machines and the time we spend on removing them basically to like negligible amount of time, probably given the scale. Then the auto-scaling we currently have in GitLab Runner is very inefficient, and Kubernetes has been built to increase utilization and exactly solve this problem. And by using Kubernetes with auto-scaling, we can shave more time, shave some costs, and be much more efficient with utilizing virtual machines and running jobs. And our assumption for now is that this way we can reduce around 50% of costs of shared runners on GitLab.com. This is only assumption, we would need to validate that, but it looks probably promising enough to iterate on that to do some next step. Is that correct?
Yeah, I would say yes. I can show you one more thing. Let me only limit it to the short runners. These are metrics showing usage on the auto-scaled virtual machines. So in last 24 hours, all of our jobs use in average 23% of available CPU.
That's incredible.
74% of memory and 28% of available disks. So this answers your question, how much we could save on putting more jobs on one node.
Another 50%. So like
maybe not, because the memory is at the level of
75%.
So probably 25%,
but
maybe even less.
But we can, this way we can create nodes that have more memory and less virtual CPUs.
Yes.
And this is another cost saving.
Try to balance this.
Yeah.
Try to balance these two.
And Kubernetes actually could do that automatically.
Yes. This is the big win of using Kubernetes for such autoscaling, because then Kubernetes, it's Kubernetes work to see and estimate how much resources are used and how more things can be scheduled on a certain node. So we would only need to observe these metrics and try to fit the VM size to the level where this would be probably at the level of 90%. So where we would use the maximum of the nodes.
That's really interesting. So I think that 50% of costs, saving 50% of costs, is something that's quite possible without, POCs and some experiments. Like the result might be different, but I think that's a good enough reason to actually do some work in this area.
Yeah, and like I said, we already want to migrate off Docker machine, and I don't remember to which release it was scheduled, but we already scheduled some issues about initial work to one of the upcoming releases, to just start doing it. So like I said, this needs to happen, and having 50% of cost saving as a result is just another big argument to do this now and don't wait anymore. But we are already being pinged by the customers what we will do with the Docker machine. People don't want to use it because it's not maintained. We needed to start maintaining our own fork of Docker machine, only to be able to help users with bigger problem, because fixes in Docker machines are not being merged anymore. So
okay, that's a huge problem.
We need to do this, and we should start with implementing the custom Docker provider interface, and then into this we can start hooking up with different ideas how to make it just the best way.
Okay, yeah, and this way we could actually run some experiments. Without experiments, switching 1% of traffic to the new way, like, it would be very difficult to actually get valuable insights. Okay, so I think that's looks very promising. I will share this video and our calculations with a broader, team, and we will see how to actually make progress, iterative progress on that. I think that what we are saying about extracting, refactoring Docker executor we have right now and the interface for that might be a really good start towards, and it would move us towards experimentation. So that's interesting. Okay. So yeah, let's take a look at the time, because the another topic I wanted to cover is CI/CD daemon, but I see that we are severely over time.
If you have time, then we can continue. I still have something about hour.
So I
can spend.
I have like 20 minutes, and I think it might be enough. So another interesting initiative, in my opinion, is the CI/CD daemon. So I managed to take a look at our metrics yesterday to see how many requests our API for GitLab Runner needs to handle, how many builds we need to serve in the API for runners to pick them up, and how many traces we actually post. And it appears that, as far as I remember, let me take a look at the issue.
I only remember that we have about 20 million requests for a new job only. I'm sorry, for the trace patching only. 20 million per day on GitLab.com.
So the amount of requests for patching the trace is currently 250 requests per second. It means that it's around 22,000 transactions per minute. And it's like a significant number. CI/CD daemon could actually help with that to aggregate some of these requests and do some work concurrently that we otherwise need to do on the Rails side. Posting statuses of builds is currently 5,000 transactions per minute. It's not like a lot, but another opportunity to aggregate some of them and make that more efficient. Getting builds from the API is currently 6,000 transactions per minute and around 100 database queries for the 95th percentile of requests. So I wonder, so the CI/CD daemon initiative is not so obvious like the firecracker or the runner efficiency improvements. That one is no brainer. We should do that, or at least iterate towards getting more metrics and insights to make more, informed decisions. In case of CI/CD daemon, I think that in order to actually do something, we need to have more data and more data and metrics to back up this idea of introducing CI/CD daemon, because I think that the idea of unblocking a ton of features, it's probably not enough for us to start working on that. So to name a bunch of features we could do, we could implement a gRCP communication between GitLab Runner and CI/CD daemon, and this way, using a binary protocol, we would probably reduce the bandwidth needed to, send payloads and receive them by 50% or even more. We could introduce new techniques, different than load polling that we currently have. We could leverage WebSockets on some kind of public publish subscribe mechanisms to create more like a serverless platform, and to be much more efficient. Then we could build a bunch of bulk APIs so that we are much more efficient in using APIs in general. And we do have a lot of ideas about distributing jobs evenly across the runners fleet, improving performance of many different parts of CI/CD code base, offloading PostgreSQL database a lot, and moving computations that it currently does to Go routines, running concurrently and making much better use of cores in processors we have on our web and API nodes. But I think that the promise of what we could build, having CI/CD daemon, is probably not enough to build the CI/CD daemon itself, and we need to iterate in a way that we work on something for a release and we see some tangible benefits of that work. And what is your opinion about things like that? What is a tangible benefit we could see after working on CI/CD daemon for a month or two?
The first time when we discussed CI/CD daemon in the past, we wanted to do this because of the job queuing, and I think this is still the biggest, the most important reason to start this. Like you just said that we have 5,000 transactions per minute for requesting a new job. Now, each of these transactions is a set of huge queries. Huge queries that, because the way how our jobs queuing works is fully related on the database. We use database and SQL queries to find out which job would be the best choice for the runner that asked for a new job. And then we add some more internal queries to handle things like minutes quotas, to handle things like supporting group level runners or supporting project level runners. And at the end, it ends with a very, very, very complex query that is executed each time when runner asks for a new job, which now we have 5,000 times per minute on gitlab.com. This means
so
that
let me share my screen to make
yep.
like more context for other people. So this is the InfluxDB grade endpoint for API jobs request endpoint, and this is the endpoint that we use to allow runners
to get a new job.
Get a new job. And as you can see, this is the amount of transactions we currently have in the last 3 hours. Let's make it last 24 hours. And yeah, so at the peak, we have around 6,000 transactions, and this is the amount of requests per minute. So it's around 6,000 divided by 60, so it's very difficult math. It's probably around like 100 requests per second. Is that correct?
Something like that.
Okay, and we have, this is a very interesting metric, SQL query counts. It appears that, what's the 95 percentile? It's around 100 SQL queries.
Check the mean.
So the mean, is like 25. It's not
25
like
to 50. 25 to 50. But
it's
also let's look on the SQL timings.
Yeah, SQL timings. So definitely peaks are not very good. Let's take a look at mean. So we can probably calculate the amount of time and we spend on that. So we have, let's see, around 150 milliseconds. 150 milliseconds multiplied by 200 requests per second. So it appears that we spend, like, that's okay, so that it's in milliseconds. So we spend 15 seconds every second on database queries. It's probably the CPU time, so it's not like a lot. Do you think it justifies building a queuing mechanism into CI/CD daemon?
Look on it in a different way. Even if it's not a lot, it's probably the most used endpoint in that uses database in our API. The problem of this is that by the way how CI query is implemented, we generate a big load on the database. And it works to the other side. If there is any slowdown on the database, and this was a cause of multiple CI outages in the past, where we had different problems with the database. Any problem on the database means that we can have some singular 500s in GitLab UI, but the query handling just goes down. And people start going crazy because the jobs are staying in pending for for minutes,
So
for
I
hours.
completely agree that building CI/CD daemon would be something that might result in making CI/CD platform much more reliable. And this is, very important aspect of every CI/CD platform. People do depend on platforms like that, and they want to use a product that is reliable. But then reliability, like, can it be captured on metrics? How can we back up this work with data? That's something I feel like it's uh, crucial to getting it done and making progress and iterations.
Like for the normal times, the metrics you already showed. This is what we have now. I think this is not good. These timings are not good. Even if they are small, this is happening constantly. It's not the API for getting a list of merge requests that I want to put in the changelog, because this you do from time to time. And the runner asks for a new job constantly. We have currently something about 50,000 runners registered and active on GitLab.com. Each of them is asking for a new job, probably each 1 second, sometimes even more often. And if we could move this off database, I really see no reason why to even think about it. And this opens us for many things in the future. Not only the features that you said, like
gRPC.
a gRPC protocol for talking with runner. It would be nice, but the protocol that we have now, it's quite efficient for asking for jobs, for updating them.
We're using JSON, right?
What people would like to have is, for example, prioritization of the runners in the project.
Yeah,
I have shared runners enabled, I have my own runners enabled, and now if I have capacity on the runner side of my private runners, I want to use them as much as I can because I already paid for them. I don't want to pay for the runner that is not used because the jobs are scheduled on the shared runners. Now, doing this now would mean
it's
that
difficult.
the complicated SQL queries that we have now would need to be even more complicated. Or we would need to totally rewrite how we handle the query.
So my gut feeling is that with the current way of doing queuing, smart prioritization of runners, like, it's not even feasible to do that without an outage or a huge pile of problems.
You know, every idea that we discussed in the past was started with that we need to change how we handle the queuing. Whether it will be a change in Rails or a totally new thing as a CI/CD daemon, it's not the case of the discussion. We can't add any new features related to scheduling jobs with the current implementation because it's not efficient already. Adding anything else will make it much slower, much more harmful for the database, and probably way more complex if we want to work only of preparing some fancy SQL queries to handle this. Like I think Kamil recently proposed somewhere to start handling the scheduling in context of each runner, so we could prepare some initial list of jobs that could be sent to a runner, and this can be done whatever we want, but this means that we need to change the current mechanism. And
yeah,
if we want to change it, then why not to start doing this in the daemon that we talked in the past, which would give us in the future additional options like the gRPC protocol, like making some things faster because of being in the Go binary, not in the Rails, and things like that.
So I'm a huge fan of CI/CD daemon, and I think that it might be a very interesting solution, but I also want to be a devil's advocate here and try to put some counter arguments to make this, discussion more valuable. And another point against CI/CD daemon is that we could probably optimize queuing on the Rails side still. Like, there's still some room for improvements there. It would require significant refactoring. Kamil expressed opinion that he can do that and that we can still be much more efficient with queuing on the Rails side. So if we can solve the biggest problem on the Rails side, even though we don't get all the other benefits, why there is a reason to actually invest in CI/CD daemon service?
Like for me, the reason now is that we will don't need to repeat this work in the future when we will need the daemon to handle something else. Like for example, this gRPC thing. I don't say we need to do this. We can try to solve this in Rails and maybe iterate in the future, but I personally don't like to do things twice. The question is how hard would be to introduce this daemon and integrate it to the platform that we have right now, even as an experimental thing that would not be required and that we could start using on gitlab.com or staging gitlab.com to just not work with pushing this to omnibus and all of the problems that we have. So similar what we did in Gitali in the past. The main the official version of GitLab was still relying on local access to the file, and customers that had HA needed to use NFS or things like that. But we started experimenting with Gitali aside to check how this works and how hard it would be to start with the CI/CD daemon. Because if we need now 3, 4, 5 months to create this internal architecture, be able to inject this on gitlab.com, to start refactoring the QEs after this, it's probably a waste of time for us at this moment.
Okay, so
if we can do this within 1 or 2 releases, then I would really prefer to go in the daemon way, because this, like with Gitali, we have now one small microservice being the part of our product that handles things very efficient, which we couldn't do within Rails, within the previous implementation.
So I agree with you, but let me check if we are on the same page, and let's be a little more explicit so that people that are going to watch this video understand it better. So our assumption is that the things that we can, like the benefits coming from CI/CD daemon might be interesting. We might be able to build a lot of interesting features on top of that. We might be able to improve performance, but it doesn't make sense currently to invest like 6 months in building that, because there is still some room for improvement on the Rails side. But being able to foster experimentation with building something in a week, 2, or a month max is worth it, because this way we can get more insights, we can iterate better, we can validate our assumptions and discard those that turn out to be invalid. And investing like 1 release in something might unlock innovation and progress in the communication between GitLab Runner and GitLab. Is that
yes.
like, okay, so we are on the same page.
If we can do it quickly, I'd say let's do it. Let's do it, because we need to refactor the queuing, and there is no difference whether we do it in the service or in the Rails. It's only the matter how much time it will take preparing the service itself. If we can do this quickly, then let's just jump to the final solutions that we want to have. If we can't do it quickly, let's try to solve the initial problem in Rails until it's possible.
So do you think it makes sense to run experiments with CI/CD daemon only on production, in a way that we do not really include anything in a package, but we handle, let's say, 1% of our traffic on gitlab.com through the new CI/CD daemon, just to get more insights, just to understand better what is viable and what is not? and how to proceed to the next
I
iteration.
I think it makes sense, but we still need to start with a way to inject such service, because if we will point it to the 1% of the traffic to this service, then we need to somehow mock with this service what the Rails current implementation would do, because the rest of the system still
So these are technical
thinks
details. And there's probably a bunch of solutions like having a feature flag in workhorse with incremental rollout, allowing workhorse to traffic to either Rails or CI/CD mode.
Yeah. I'm saying about the fact that currently when we hit the job request endpoint, we start a Rails service that does these queries, but also fires some transitions of the jobs.
Yeah, I know. So
Count some metrics, etc., etc. So we would need to ensure that even if this queuing request is handled outside, we send to GitLab all of the information that would normally be created.
let's leave it aside. I feel like these are implementation details that we should not discuss right now.
But this is what will give us the answer if we are able to create this within, for example, one release.
So we probably need to work a little bit more on figuring it out. What actually can we do in one release that will allow us to gain more insights, to see something on metrics, to understand this problem and this project better and how viable it might be to invest in the next iteration. So let's leave it aside. I scheduled another meeting to discuss exactly this problem. What can be done in the first iteration to gain more insights and to decide whether we want to proceed with CI/CD mode to the next iteration or not. So that we do have a meeting scheduled for that. I think it's scheduled for the 7th of May. I can't remember, but you've been invited to that meeting.
Okay.
As well. Okay, so I think that we are over time, and that's like a lot of useful information and discussion. And I'm going to share that video with a bunch of people. Let's see what their opinions about the Firecracker and CI/CD mon are. And we will probably discuss this further in next meeting. So thank you very much. And I'm going to stop the recording now. So
okay.
yeah, thanks.
No problem.